Hello there. So now let's talk about radicals that are different than the square root. For example, cube root, or fourth root, or fifth root. So just to remind you of what this would look like, if I ask you what say the cube root of 125 is, that's going to be 5. And that's because 5 cubed is 125. If I ask for the fourth root, say, of 16, that'll be 2, because 2 to the fourth is equal to 16. And so if we say in general that the mth root of A is equal to B, that means that B raised to the m is equal to A. We call this number here the index. So in passing, we made a list in the previous video of the numbers you can take the square root of, and those were perfect squares. Perfect cubes are the numbers that you can take the cube root of and get a nice integer. So 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. Perfect fourths, 1, 2 to the fourth, 3 to the fourth, and so on. And so you can make a list of those and keep them so that when you're looking for the third root or the fourth root, those are the nice numbers, the numbers such that when you take the cube root or the fourth root or so on, you get a whole number, an integer. So for example, here's a fairly simple problem. Suppose we have 3 times the cube root of 54. Well, just as before, what we want to do is take 54 and write it as the product of a perfect cube and whatever else works to give you 54. So, and that's going to be 27 times 2. The cube root of 27 is 3. 3 times 3 is 9, so this is going to be 9 times the cube root of 2. Follow that? Skipped a couple of steps, but you guys are getting smarter now. So just to kind of keep track of this, I know that the cube root of x cubed is x. What's the next power of x that I can take the cube root of? It's x to the sixth, and that's going to be x squared. And that's because x squared cubed, what do we do with the exponents? Multiply. So the powers of x that you can take the cube root of are all multiples of 3. Just like the powers of x that you could take the square root of are all multiples of 2, which are even numbers. And the same thing with fourth root. For example, I can take the fourth root of y to the fourth. That's y. But I can also take the fourth root of y to some number which is a multiple of 4, like 20. And that's going to equal y to the fifth, because y to the fifth to the fourth is equal to y to the 20th. Get it? It all comes back to these properties of exponents. So now let's check out this last example. We're talking about the fifth root. In other words, the index is 5. So the powers of x or y or t that you can take the fifth root of are multiples of 5. And so that's what I'm going to do here. I'm going to write this as 3 times the fifth root of, okay, now, if we look at 128, what factor does it have that you can take the fifth root of? 32. And now we're going to take multiples of 5. So it's going to be x to the fifth, y to the 10th, t to the 20th, and what am I left with? I've got a 4, I've got an x to the fourth, and I've got y squared. Okay, that's the big deal. So this is going to equal 3 times 2 times x times y squared times t to the fourth times the fifth root of 4x to the fourth y squared. And this can be simplified a little bit more as 6xy squared t to the fourth times the fifth root of 4x to the fourth y squared. And there you go. That's as simple as it can be written. Okay, so that concludes this particular section.